Welcome to 3D visualization of gINT subsurface data in MicroStation. My name is Strahan and I'm a Senior Application Engineer at Bentley. Today's e-seminar assumes that you have some basic knowledge and understanding of both gINT software and MicroStation in order to understand the steps presented. Our starting point is gINT database. This is a gINT database used in this presentation. It's a standard gINT database with standard fields and standard tables. Let's go to the borehole table. By observing borehole table, we can see that there is 25 boreholes saved in this table and that we are going to export to MicroStation. Observe that surface elevation as well as coordinates, let's say northing and easting or lat and long, are entered for each borehole, so we can locate boreholes on a sitemap. Orange color for these fields is optional. Let's observe our boreholes on a sitemap. We can see that we have a big sitemap imported in gINT. I'm going to zoom in to our area of interest. Now we can see locations of boreholes. We are going to export this sitemap along with borehole locations into a MicroStation. Our final result is going to be a 3D model of subsurface data along with a sitemap and borehole locations. Let's go back to gINT and export sitemap with borehole locations. Under File menu, Import Export, we can see that we have Import Export commands to import the XF file, which can be any drawing with a sitemap, and we can the XF export anything that we can see in this drawing area on the screen inside of a gINT. At this time, we are going to export sitemap with borehole locations. We are going to name this sitemap. Notice that this is the XF file, and we are going to save that as step 1. Export is completed. And now we can observe some of the reports. First of all, let's see a borehole report. So this is a standard borehole log. Many of you may be familiar with that. Zoom back. Let's go and exit preview. Let's go to output and also create fence report. I'm going to go to the site layout. Again, we are going to see boreholes, and I'm going to create a baseline, or I could use alignment if I imported it in gINT. Create a baseline, and I'm going to select boreholes that I want to project to that baseline. Baseline represents a vertical plane, subsurface profile. Return to output, and let's preview that. So we can already imagine that we are going to have approximately 3 layers to model subsurface strata. Exit preview. Let's observe some other reports. A sitemap report, for example. So we already seen a sitemap in input mode, but there is also like a sitemap as a report. I'm going to preview a sitemap report. Again, I'm going to zoom in. This time we can see that there is a logo, a title, and we can apply different colors and actually a different logic for this report to show different things in different colors depends on some decision-making engine built into the report. And exit. So this was a standard gINT overview of some of the reports that you can create with gINT. At this point, we are going to focus to gINT functionality that enables us to create point files and supply them to MicroStation for modeling. So let's go back to gINT and apply reports that create point files. In this case, we are going to use text tables. And we are going to select point file elevation top of sand. Let's preview that report. In essence, this is a very simplistic report that gives us X or easting, Y or northing, and stratum top elevation. In this case, top of sand layer. Elevation of the top of the layer is calculated based on the depth of the layer and the elevation of the borehole. I'm going to exit preview and name the file gINT export top of sand. We are going to check view document after export and click export. This is going to open a notepad or text pad, and I'm going to remove first 2 lines in that file, delete them, save the file, and close it. Let's repeat the same procedure for top of clay. Delete first 2 lines, rows, save, close. Top of bedrock. Save and close. And finally, elevation borehole bottom. Save, close. And this completes the exercise of exporting point files from gINT, which are ready to be imported in MicroStation. And now we are going to proceed with importing point files in MicroStation. Let's switch to MicroStation. And let's open sitemap DXF that we exported from gINT. Open it. Select feet for units when prompted. And OK, so this is our sitemap we exported from gINT, and we can observe our borehole locations here as well, exported from gINT. I'm going to save that file in a native DGN format with the same name, DGN. Before we proceed with importing points, we're going to go to Level Manager and create certain number of levels. 4 levels for points and 4 levels for meshes. Points, top of sand, top of clay, top of bedrock, borehole bottom, and meshes, top of sand, top of clay, top of bedrock, and borehole bottom. I'm going to set gINT points top of sand level active because first we are going to import top of sand points. And I'm going to also turn off all other levels. Under Tools, Dimensions, there is XYZ text command, import coordinates. I'm going to browse to gINT export top of sand text file we export it from GINT, open it, and then I'm going to click Process. Now we can see that we imported points that represent top of sand layer or stratum. This point we are going to do the same thing with other points. So I'm going to set GINT points top of clay level active. I'm going to turn off GINT points top of sand and do the same procedure to import these points for top of clay. This time I'm going to select top of clay, GINT export, open, process, and now we have imported top of clay points. And we repeat the same procedure for importing two remaining text files. Step 3 is creating meshes in MicroStation based on points that we imported. Let's switch to MicroStation. So at this point we are going to set GINT mesh top of sand level to be active, and we are going to turn off all the levels except GINT points top of sand level and GINT mesh top of sand level. This will display us only top of sand points, and we are about to create mesh that is going to be created in GINT mesh top of sand level. I'm going to go to the mesh modeling and select command mesh from points, and then I'm going to select all the points. Observe that there is an option keep original, which I'm going to check. So basically that means I'm going to keep the points, and I can also check if I wanted expand to rectangle, which is some sort of extrapolation. Okay, I'm going to create, select, and create mesh. This is my first mesh. I'm going to now set GINT mesh top of clay level to be active, and I'm going to turn off all the levels except GINT points top of clay, and repeat the same procedure, mesh from points, keep original, and then select points and create mesh. So at this point I have two meshes created, and I can observe that by rotating the view. Next, we are going to edit meshes that we just created in MicroStation. Let's switch to MicroStation again. So we'll switch to wireframe mode, and this time we will use command called under mesh modeling called create base. When I click on that command, this dialog box will show. We're going to tick thickness, and we are going to enter value that is arbitrary value, but it has to be thicker than the layer or stratum that we are creating. So I'm going to select 50, and I'm going to enter 50, and then I'm going to select top of sand mesh, which is represented by yellow color. We can see also arrow pointing down. That means that we are going to actually extrude that mesh downwards by 50 feet. I'm going to click inside of the screen, and this is going to extrude the mesh. I'm going to repeat the same procedure, this time with -50, and select top of clay level, and that arrow now is pointing up, so the top of clay mesh will be extruded upward. So basically I have two meshes right now that are extruded downward and upward. Now I can do some Boolean operations on them. What I'm going to do is a command called mesh intersect. So I'm going to actually find a mesh, resulting mesh of intersecting these two meshes. And again, I have option to keep original if I wanted so. And I'm going to click to one mesh and then another inside of the drawing area. And here it is. This is my resulting mesh. So basically right now I have a mesh, a single mesh, that is consisted of top of sand and top of clay level or layer stratum, and top of clay level or stratum coincides with the bottom of sand. So basically what we're observing right now, it's a sand level, a sand stratum inside of the MicroStation. And the last step we want to perform is convert meshes to solids in MicroStation. So let's switch to MicroStation once again. Let's turn to wireframe mode again. And under surface modeling, there is a command called convert to solid. I'm going to run this command and the dialog box will show up, and there are two types of solids I can create, smart and primitive. You can refer to help to find out about differences. I'm going to select smart solid. I also have option to keep original. This time I won't, and click to it, and again in the drawing area. Finally, I'm going to go to element information and select that, and I can see now that I have smart solid created. I have all the properties of the solids I can explore, and I can go to drawing. I can also find out about volume. I can measure volume for the solid in different units. And you can imagine that, for example, this can be a volume presenting a soil that has to be replaced in an environmental project, or maybe a portion of the stratum that has to be cut out in the road design project, and so forth. So in similar manner, we would create meshes and turn them into solids for other three layers or stratum, and our resulting drawing would look like this. In this very example, I also added boreholes, and basically I created them as 3D cylinders, and we can see a sitemap at the bottom, and apply different displays and different daylighting. This concludes 3D visualization of gINT subsurface data in MicroStation. My name is Strahan Toljak, and thank you for your attention.